Okay, so here's your packet lesson, section 4.4, day 1, and we got a lot to cover, so let's just do it. So in the pre-lesson, we were talking a lot about these sort of things, and the actual example I gave you, the last example, was this, and I said, okay, read that, and you said 10, or we said, 10 to the second power equals 100, because this is our base, this is our exponent, that's our answer, and that's how you get it from a logarithmic equation to an exponential equation. These are the same things, okay? Now with that in mind, let's say this was the problem. See that? Now I want to draw your attention to this. Evaluate the logarithm. And let's take it to this problem right here. Evaluate really means solve. Solve for what? Whatever's missing. So what's missing in this one? This part. Now I know you guys could say, oh, it's 2. But let's act like you don't know that. What would you do? If you just followed the rules of logarithms, the first thing you would do is turn it into an exponential equation. So you'd take the base, go like that, look at that, and you'd say, that's my exponent, and you'd say, hey, that's in the position of my answer. Now, I know that you guys at this point could go, aha, it's 2. But I want to draw a lot of emphasis onto this. Common bases, happy places. Now, in this example, it's not that big of a deal because we can just go, oh, 10 squared is 100. But on future sample problems, if you don't know this little skill, you're going to be in deep doo-doo. What I mean is, all right, I got a 10 and I got a 100. Captain Obvious, which one of these is bigger? The 100. So I'm going to make that common bases. So I'm going to write that 10 squared, and notice what happens. If we got common bases, then we know these exponents have to be equal. So we'd say, aha, x is equal to 2. Keep that in mind as we go into these problems. So this says evaluate the logarithm without a calculator. Yes, there's an easy way to calculate some of these with a calculator, but there's a twist to that. And we don't have time to talk about it right now, but here's what this wants you to do. It wants you to put in the missing part and then ask yourself, okay, what do I do next? There's my base. There's my exponent, and there's my answer. Now over here I said common bases, happy places. That's not going to work over here because we got a 6 and a 1. A little common sense needs to come to your rescue. What do we need to raise something to? What power to get a 1? Well, that is always going to be 0. X equals 0 because anything to the 0 power is 1. That's just a common sense special. That fits in its own category. This will fit, kind of connect to this a little bit better. So what do? We put an x in the missing piece. Here's my base. Here's my exponent. There's what's in the position of my answer. Now this you could just figure out because 3 times 3 times 3 is 27. Times 3 is 81. So we know that's 4. But let's act like we don't know it. Common bases, happy places. And then we'd go, okay, and then the 3's kind of drop out, and I can see that x equals 4. Now they're going to get a little nasty, so watch this. I got to put my x in, and I'm going to go to my base, then my exponent, then this crazy looking thing, 1 over the 5th root of 36. Wow. Now is where this is going to be very important, plus your lesson on exponents. Well, I see my 6 and I see my 36. So I'm going to change that 36, watch this now, to 6 squared. I'm one step closer to having common bases. Now I need to think of this as 6 to the x equals, watch this. Remember my rule where I can put this power over the index? 1 over 6 to the 2 over 5, or 2/5. And then if I bring a positive exponent up, it becomes negative, so I got 6 to the x equals 6 to the negative 2/5, and I can say, hey, those bases disappear, and x equals negative 2.5. This one, when you don't see, for example, if you see x, isn't there an invisible 1 here and an invisible 1 here? The answer is yes. When you see the square root of 49, we don't put that 2 in there, but there is an invisible 2. So listen carefully. In math, there's always invisible stuff. You notice there's a base missing? Now, when this happens, it is to be assumed that that's a 10. And then you put your x in, and you go start here, go here. So 10 to the x power equals 10,000. Now, right now, you could say x is 4. But let's go 10 to the x equals 10 to the 4th. And now these disappear, and x equals 4. See, some of them are easy. Some of them are a little challenging, like this one. How about this one? Well, there's a missing base. It's a 10. And I put my x in, start here, go there every time to the x power equals whatever's in my answer spot. And look at this one. It couldn't get any easier. So the 10s, I've already got my common bases, so x equals negative 4. This one gets a little more challenging. Again, there's a missing base 10 there. That's a 10. Put my x in there, start here, go here, always. 10 to the x equals 1 over the square root. Now I know this 1,000 needs to turn into 10 to some power. So I'm going to do it right now, 10 cubed. What's the invisible thing right here? A 2. How should I rewrite this? 10 to the x equals 1 over 10 to the 3 halves. What do I do if this is stuck down here? Bring it up. So I get 10 to the x equals 10 to the negative 3 halves. Then these disappear. X equals negative 3 halves, and we're done. Now, I haven't mentioned this yet. I haven't even brought it up. But when you see this ln, it's called a natural log. Now, strangely, you know, the number pi, we all know is 3.14. There's another number, e, which is approximately 2.71. Maybe it's the first time you've been introduced to it. But you can see there's an e here and there's an e here, but there's more to it. Just like when this base was missing on an log log, we made it a 10. If this is a natural log, and there's a reason why they put the L first and the N first, but I'll talk about it when it's significant, which is right here. But we'll talk about it right here. When the base is missing, you just have to know that it's an E. That is considered a natural log if the base is an E. And now I put in the missing piece. Here's my base. Here's my exponent. Here's what's in the answer position. And then I go, wait a minute, I don't even need to know what E is. You're right. Then X is negative 4. Here's the one that explains why they put the L in front of the N, and even though it's natural log. If they didn't, it would look like this, N11. And that doesn't work. So they switch it up for situations like this. Well, there is an invisible E here, and you have to put in the thing you're trying to find. Here's my base, here's my exponent, so it goes a little something like this. Base, exponent, answer. Once again, it's very similar to this one. Anything to the 0 power is 1. And that's what this must be. X is 0. That's a common sense special, but you have to see it. Now things are going to get a little nasty. There's an E there. Got to put my X in. Base, exponent, so e to the x equals, this is a bit messy, square root of e to the 7th, which is e to the x equals 1 over, remember there's a little 2 there, e to the 7 halves. Now I'm going to bring this up, so I get e to the x equals e to the negative 7 halves. These bases cancel, and x equals negative 7 halves. Now these, we're just going to use our calculator. So, all right. Now why can we use our calculator? Because when you hit the log button, your calculator is programmed to know that there's a 10 down there. It will handle it. If you tried to do these with your calculator, we'd be in trouble because your calculator is not assuming that your base is a 3. It's assuming that your base is a 10. There's a reason for that, and that is our number system is called a base 10 number system. I do have 2 seconds, so I'm going to go ahead and take these 2 seconds. Let's take the number 231. That's 2 times 10 squared plus 3 times 10 to the first plus 1 times 10 to the 0 power. That's 231. That's why our number system is considered a base 10 number system. So when I take my calculator and I turn it on, clear that out, all I'm going to do is find my log button right here. I'm going to take the log of negative 5.14, hit enter. I just realized I did example 11 instead of example 10. I wasn't sure why there was an error there. But we got error for this one. The question is why? Why is this one error? If you think about it, there's an invisible 10 there, and we'd say 10 to some power equals negative 5.1. That's not going to happen. There's no way that can happen. Let's go to this guy. So I'm just going to go log of 0.908, enter. I get negative 0.041. Negative 0.041. Now how about this guy, natural log? Well, I'm going to go here, natural log, and I'm going to go 0.733, enter, and I get negative 0.31. Negative 0.31. And then this one, I can already tell that this is going to be an error, but let's go ahead and do it. Natural log, negative 3.3, enter. Now why does that say error? Think about it. There's an invisible e here, and you're actually going e to some power equals a negative. That's 2.7 to some power equals negative. That will never happen. That's why it's considered an error. And that does it, you guys. That finishes up 4-4 day 1.